In today's installment, China unveils an ambitious new strategy to traverse the solar system, as NASA makes a remarkable discovery on Mars. The European Space Agency refines their Mars landing plans, and Europe's inaugural rocket experiences an unforeseen journey back to its point of origin. China has formulated a comprehensive plan encompassing most of our solar system, spanning from Venus to the distant realm of Neptune. Much of this proposal appears reasonably achievable, though certain elements venture into truly extraordinary territory. The Chinese have recently established a novel organization named the Deep Space Exploration Laboratory, designed to enhance the nation's systematic approach to surveying the solar system. This laboratory represents a collaborative effort between China's National Space Administration and the University of Science and Technology of China, has demonstrated considerable activity in lunar exploration, including pioneering rover operations and sample retrieval from the moon's far side. The Chinese also became the second nation following the United States to successfully operate a rover on Martian terrain, bringing substantial experience and credibility to their endeavors. The roadmap begins in 2028 with the Tianwen-3 mission to Mars, which will gather specimens of Martian soil and rock formations for direct transport back to Earth. This represents a previously announced initiative, and it remains encouraging to observe the plan progressing as scheduled. Should it succeed, it will mark the first ever Mars sample return mission, barring any intervention from Elon with a Starship vehicle. In 2029, Tianwen-4 will undertake exploration of Jupiter and its moon Callisto. This represents another previously discussed mission with a compelling operational profile, as Tianwen-4 will operate alongside NASA's Clipper mission studying the Jovian moon Europa and the European JUICE probe primarily examining Ganymede. This coordination will provide detailed observations of 3 among the 4 major Jovian moons, leaving Io as the sole exception. The year 2030 will witness developments on Earth, as China advocates for constructing a substantial ground-based habitat to replicate extended human spaceflight conditions. This facility can essentially be characterized as a simulator for Mars and moon base operations. By 2033, a mission to Venus will retrieve atmospheric samples for return to Earth. This undertaking appears quite audacious, though much depends on the intended depth of atmospheric penetration. A glider-type vehicle could descend into the atmosphere, or a balloon could drift through it, collecting gaseous samples before igniting propulsion systems to achieve orbital return. This marks the first credible Venus sample return mission proposal encountered. The year 2038 will see establishment of an autonomous Martian research station focused on studying in situ resource utilization. This essentially describes a robotic Mars base, likely resembling China's planned International Lunar Research Station in concept. The goal remains similar: establishing groundwork for sustained human exploration. In 2039, a mission will target Neptune's largest moon, Triton, incorporating a subsurface exploration vehicle for the moon's ocean. Similar to Europa, Triton is theorized to possess an icy exterior shell concealing a saltwater ocean beneath. The thickness of this shell remains uncertain, making any presumption about drilling or melting through it to deploy a submersible vehicle highly ambitious. This ambition seems particularly bold considering mass constraints when dispatching equipment to such remote regions of space, unless more efficient propulsion systems can be developed by 2039. Nuclear-powered propulsion represents a potential solution, and that possibility isn't unreasonably distant. This roadmap will certainly command considerable attention and observation throughout the coming years. The timing proves significant, coinciding with a period of substantial uncertainty at NASA. The agency confronts potentially severe budgetary reductions, lacks a confirmed director, faces challenges with the Artemis program, and their Mars sample return mission is currently being reconstructed with international and commercial partnerships. One certainty remains: NASA continues conducting remarkable exploration activities on Mars, and their latest discovery using the Curiosity rover possesses genuine potential to captivate public imagination. For those not monitoring developments, Curiosity represents the elder of 2 current Mars exploration vehicles. It departed Earth in 2011 and operates as a nuclear-powered 6-wheeled robot approximately the dimensions of a mid-sized automobile. Curiosity has detected something unusual within a Martian rock specimen, the most extensive organic molecules ever identified on the red planet. The significance of this finding requires clarification. An organic molecule doesn't automatically indicate confirmed alien life. It simply denotes a molecule containing carbon, which forms the foundation of life as understood. The term large refers to long-chain carbon molecules, indicating structures containing numerous atoms linked in sequence. These represent microscopic entities. On Earth, relatively intricate long-chain carbon molecules correlate with biological processes. These Martian molecules could potentially represent fragments of fatty acids, commonly present in membranes enclosing biological cells. Any evidence of life discovered on Mars will necessarily be microbial in character, as a life-supporting environment likely didn't persist on Mars sufficiently long for more sophisticated life forms to develop. However, the diminutive size of microbes makes definitive identification extremely challenging. This category of evidence demands considerably more sophisticated scientific equipment, too substantial to transport aboard interplanetary rovers. This underscores the necessity for sample return missions. The organic molecules identified by Curiosity appear composed of carbon atoms arranged in extended chains, with additional elements like hydrogen and oxygen bonded to them. They originate from a 3.7-billion-year-old rock designated Cumberland, which the rover encountered in a desiccated lakebed within Gale Crater. Scientists seek to confirm evidence of amino acids on Mars, which constitute the fundamental components of proteins and essential elements of life as known. Nevertheless, long-chain hydrocarbon atoms represent a profoundly exciting discovery. Among the identified molecules were decane, containing 10 carbon atoms and 22 hydrogen atoms. There's also dodecane, comprising 12 carbon atoms and 26 hydrogen atoms. These belong to alkanes, falling within the broader category of chemical compounds classified as hydrocarbons. Discoveries of this nature provide fuel for future Mars exploration initiatives, including the Chinese missions previously discussed. A significant plan also advances at the European Space Agency. ExoMars represents Europe's third endeavor to achieve successful landing on the Red Planet. In 2016, ESA's Schiaparelli Mars lander impacted the surface following a computer malfunction. In 2003, the European Beagle 2 lander successfully contacted the Martian surface, but solar panel deployment failed and communication with Earth never materialized. Considerable pressure accompanies ExoMars to succeed where previous attempts faltered. Substantial financial investment rides on this mission, $1.3 billion in expenditure. Unsurprising considering this mission has been under development for 2 decades. ExoMars was initially scheduled to launch aboard a Russian Soyuz rocket in 2011. Since that time, the mission architecture has undergone multiple revisions and reconceptualizations, with various international partners joining and departing. At one stage, this would have represented significant collaboration between Europe and Russia, though that scenario no longer applies. Despite these challenges, positive developments have emerged. Recent announcements indicate that French aircraft manufacturer Airbus will assume the Russians' role as constructors of the ExoMars landing platform. This landing platform comprises the ExoMars spacecraft component, managing final descent phases toward the Martian surface. Following touchdown, the platform will extend ramps enabling the ExoMars rover, named Rosalind Franklin, to traverse onto Martian terrain. Presently, ESA maintains reliance on NASA for Mars transportation. After the dissolution of the Russian partnership, the mission could no longer depend on a Proton launch vehicle. NASA has committed to providing a rocket, an engine with adjustable thrust for the descent module, and radioactive heating units. The specific rocket selection remains undetermined, but ExoMars requires sufficient capacity that something comparable to a Falcon Heavy, ULA Vulcan, or Blue Origin New Glenn will be necessary for departure. This mission tentatively targets a December 2028 launch date, again unless Elon can intercede with his fleet of Starship vehicles. Speaking of rockets that explode, a European aerospace enterprise known as ISAR finally launched their inaugural rocket, designated Spectrum, this past week. However, it never reached space and instead executed an unexpected return to the launch facility. ISAR operates as a small space startup that has been developing a small satellite launch vehicle since the mid-2010s, known as Spectrum. The rocket would better serve Europe's small satellite industry by launching from their own continent at the Andøya spaceport in Norway. This flight has been in preparation for years, and finally, early last month, ISAR received authorization to launch their first rocket. This represented the first orbital launch attempt from mainland Europe beyond Russia's borders. It also marked Andoya's inaugural use as a spaceport. Approximately 30 seconds into flight, the rocket initiated a planned pitchover maneuver to begin accumulating horizontal velocity. This proceeded catastrophically wrong, and the rocket rapidly oriented with its nose directed back toward the Norwegian island. The rocket's attempt to compensate for unstable flight through engine gimbaling was visible. For the initial 20 seconds, it oscillated somewhat before inverting and descending back to Earth. The flight concluded with impact into nearby icy waters and a fiery detonation. While this terminated the flight and broadcast, it simultaneously initiated numerous questions regarding the failure. Some answers arrived several hours later when company leadership participated in a discussion call regarding the incident. While they declined to specify exactly why the rocket lost control, it was disclosed that the flight termination system activated in response to the oscillation, shutting down its 9 Aquila engines and causing the rapid return to launch site. This proved somewhat unusual, as typically the flight termination system detonates the entire stack rather than merely shutting down engines. Perhaps different protocols apply when rocket altitude remains extremely low. Observing one simply descend like that was unprecedented. Obviously, this represents a disappointing outcome for the company. However, they also characterized it as successful within their assessment due to valuable data collection achieved. Additionally, they preserved the launch pad's integrity, meaning they can immediately resume testing operations.